Well, welcome to this online revision session for AQA M2, which we'll be looking at the January 2010 question 5 on kinematics involving differential equations. As you can see, we've been given the golf ball of mass m moving in a straight line across horizontal ground with a speed v, meters per second, and it has a resistive force of 0.2 mv to the power of a half newtons until it comes to rest. It's modelled as a golf ball as a particle, and firstly we got to show that dv by dt equals minus 0.2 v to the power of a half. Well, that first part we know that force is equal to mass times acceleration, which can also be written as mass times the differential of velocity, dv by dt. So we can write that m dv by dt is equal to the force. Now we're told it's a resistive force, which makes that negative 0.2 mv to the power of a half. So you can see the mass will then cancel from both sides to give us the required results. And just working through that quite simply gives us that 1 mark. In the next part of the question, we've been told that when t is 0, the velocity of the ball, the speed of the ball is 16 meters per second. We got to show this expression for v. So that will mean taking this result in part A, and by separating the variables we can integrate the expression. So if we separate the variables, we will get v to the power of minus a half, bringing the v to the half to the same side as the dv, equals the negative 0.2 dt. And then to make that an appropriate piece of mathematics, we need to integrate both sides. Well, the integral of the right-hand side, the left-hand side, will become v to the power of a half, and we divide by the new power, so that becomes 2, dividing by half. And then the right hand side will become negative 0.2 t plus some constant of integration. Well, what do we know? We know that when t is 0, v is 16. So we can substitute those conditions in to determine the value of c. So if we do that, we will get 2 times 16 to the half is equal to c. So c must be equal to 8. So now we can substitute that value for c of 8 back into the relationship that we'd got from the integral to give us 2v to the half equals negative 0.2 t plus 8. And now all we've got to do is to make v the subject. So if v to the half is equal to, we'll divide through by 2 and put the positive part first. And that gives us the 4 minus 0.1 t, and then we can square root this. So v will be equal to, when I said square root I should have said square both sides. So we square both sides to give us the required result. Well, it's 5 marks for this, so it'll be 1 mark for realising that we needed to separate the variables. And we'll have an answer mark for this expression, and we also get a method mark for having the plus c in there as required. Then determining the value of c as 8 gives us a mark, and then finally working through from there with that value of 8 to get to the required result gives us a mark. Part C, we then got to determine the value of t when v equals 0. Right, so what have we got? Well, substituting in v equals 1 is going to give us 1 equals 4 minus 0.1 t all squared. So we have to solve this. So if we square root both sides, that gives 4 minus 0.1 t equals plus or minus 1. Rearranging this will give us 0.1 t equals 4 plus or minus 1, which will give us either 3 or 5. And so divided by 0.1 multiplying by 10, that gives us a t value of 30 or 50. It's given us two values, but if you notice it said value, so why and which one of these do we use? Well, if you remember, it said the force was only applied until it came to rest. Well, it will come to rest when t is 40. So the 50 value is not relevant. So we know that t has to be less than or equal to 40 for v to be positive. So before it comes to rest, so that implies that t can only be 30. Okay, so again, a method mark for realising we have to solve this equation. And then for getting t as 30 and 50, you'll get 1 mark. But then reasoning that t can only be 30 will give you the 3rd mark. Finally, in part D, that's part C, part D, we're being asked to find the distance travelled by the golf ball as its speed decreases from 16 to 1 metre per second. Well, 16 was the initial speed when t was equal to 0. So we can put when t is 0, v was equal to 16. And we can assume that the distance travelled at that point is 0. That's our starting point. Now we've just shown that when t is 30, v is 1, and we now want to find the distance at this particular juncture. Well, to find an expression for the displacement, we will need to integrate the velocity. So we've got to do the integral of 4 minus 0.1 t squared dt. And probably it makes sense just to multiply this out, so we get 0.01 t squared minus 0.8 t plus 16 dt. So when I integrate this, I will get, well, what am I going to get? I am going to get 0.101 over 3 t cubed minus 0.4 t squared, so that was t squared over 2, plus 16 t plus a constant. Now, because of what we've written here, when t is 0, v is 16, d is 0, then that will imply that c's got to be 0. So my displacement is just going to be given by this expression plus 16t. And so, if we now substitute in t as 30, that will give me the distance as being 0.01 over 3 30 cubed minus 0.4 times 30 squared plus 16 times 30. Which in turn is going to give me, well, one of those threes, the hundreds will go, so that's 20, forgetting about the 10 bit on the end, you're going to get 27 over 3, which is 9. And then you've got, that's times 1,000, which is going to give you 10 times that, so that becomes 90. Minus 30 squared is 900 divided by 0.4, that's going to give you 90, and 90 divided by 4, oh, sorry, times 4 gives you 360. And then the 16 times 30 is 480. And so in total that will give you a result of 210. Oh, got there. Right, so again, marks for this, for ending up with this expression here from the integration will give you a method mark. For obtaining the constant there as 0 will give you an answer mark there. And then for then substituting in t as 30, again give you a method mark through to then working out the correct value for the final answer. Okay. Hopefully you found that solution helpful. For more assistance with your maths revision, please go to the Further Maths Support Programme website.